So today I'm going to talk through the linear regression example code that we sort of talked about in class, but at least there's a recorded version of it, but then also how you can sort of use some of the existing homework assignments or get a blank version of homework assignments, or how do you actually go and use this code that I'm giving you to study for the exam. We talked about bits and pieces of this in the actual class, but uh, probably better to get it recorded and reviewed again. So, um, first thing is there's been a couple of questions around how do we go and get a new version of your current homework assignment so you can at least work through it. Luckily, during finals week, there's no more homework assignments that are due. So if you do something weird with your actual repository, there's less of an issue about like affecting the rest of your coursework. So with that said, the for the question around how do you go and make a start a new assignment or get a blank version of your that's interesting blank version of your current homework assignments is we have our github.com/ubc-dsci/dsci 100 student Python repository. And if you go there, there's a folder called materials, and it's literally exactly formatted the same way your Jupyter labs are for your homework assignments. And here are all of your homework assignments in the original form, which means that you can, for example, we are going to talk about regression one today. So regression one, you can go and click on this file, and this is the actual original regression one homework assignment that you were given. What you can do is click on this raw button, and then this is the actual Jupyter notebook. What you can do from here is you can right click this file. So one, it's really important you are looking at the raw view, and then you can right click save as and save that file to your computer. And that is your Jupyter Lab file. The next thing that you can do is open up Jupyter Lab on your local computer through Canvas, just like you have been for all of your homework assignments. Start your server, and essentially you can go and wait for this to load, navigate to the exact folder that you had before. So we're looking at regression one. I forgot if it was the worksheet or tutorial, but you can go to your regression one folder, and then from your download side, yes, you can rename this file, and I would say call this like original or like empty, or yeah, let me spell it correctly. Empty. And then once you rename it, you can drag it back into your Jupyter Lab, just so you don't end up replacing the original file. And then once you double click it, it will behave just like an empty notebook. So you can, how you want to rename your files right now, it won't matter. Maybe you rename the original one there that says like this is what you submitted for homework, and then you can drag a new one in there if that will help you with some of your studying. So that's how you get a new Jupyter Lab assignment without trying to download everything, try to get it running on your computer, and leverage the same mechanism that you have been using for your homework assignments. So hopefully that was okay for the people who are like here like live. Those instructions were clear. Okay. So today, let's talk through some of the things around regression. So and we have two more of these office hour sessions, so I'll go through another block of code and I'll send you a little bit more block of code as we go. Um, so let's talk about regression. Um, there is going to be a lot of code. Like, for example, everything that I have selected here is code that you don't need to know for the exam. So I will, as we finish these sort of code reviews, like, and like need to know. Um, I'll put like these little markers like don't need to know, right? So I'll put like some set of markers or comments in the code for things that like you should know, and that's where we'll go with the actual code. Okay, so right now we will be working. So let me run this block of code just to make sure things are working. Cool. Okay, so here is our data set that we are talking about or going to work through for reviewing regression one. So if you also remember how the topics were covered in class, regression one was k-nearest neighbors for using in regression mode. So we have this data set around house information about particular homes, and maybe the question that we're asking about is the actual value of that particular house in $100,000 units. So this 4.526 stands for 4.526 like thousand 450, yes, $452,000 is what that number will represent. So I think you don't need to know. Yeah, there's like almost like this part that you don't need to know. You do need to know how to split your data. So this train test split is something that you have been using throughout the course. So again, this is so we can get training data and testing data. So if we're thinking about understanding what's happening with code line by line and using that as a mechanism to study and understand what's going on with the concepts that's happening, it's not that like, oh, we're doing train test split. The question you need to ask yourself is, why are you even doing this step? And then why is we are working on a prediction model. In this particular case, it's going to be k-nearest neighbors in regression mode, but we're doing a prediction model. So that means that our main goal is to fit a model that can predict on new outcomes, like a new data point. And so we don't want a model that is so good at reporting the data that we feed it, because that's almost like if I give you the same exact exam, you'll be really good at taking this one exam, but you might not be like good at taking a new exam, even if the content is the same, right? So that's also why um, if you end up just retaking the same practice exam, that doesn't necessarily prepare you for the actual final exam, something like that. That's sort of the same analogy. So we need a mechanism to say, hey, let's do a whole bunch of practice and learning on a training set, and then do the final validation of, hey, this is actually the real assessment on a training set. So that's why we're doing this particular step. And then you can think about the mechanics of what's going on inside. Like, yes, this puts in, and this is part of it is because of how scikit-learn works. It doesn't come, all your data doesn't come in one data frame. So there's bits and pieces around that. But there is like a parameter in here called test size equals 0.2. And that is saying that, hey, given my entire data set that I'm feeding you, please reserve 20% for the testing set. And again, then you go back and try to review what is training, what is testing, why is it called training, or you don't necessarily need to know why it's called training, but like what is the difference between training and testing? Okay, so Next, this particular code, give me 1 second. Oh yeah, okay. This particular code then goes and says, hey, we're going to create a make column transformer type of preprocessor. So why are we doing column transformers? Why do we even need to transform any of our data? Let's assume that the data set that we have right now, so for example, the housing data set here, it looks tidy, right? So we don't necessarily have to do data cleaning, but why do we still have to process our data? Well, then we go and ask the questions around what type of model are we working with? We are working with k-nearest neighbors, and the core mechanism of how k-nearest neighbors works is this notion of calculating distance between one point to the other. And so distance really matters, and you have to have distance on a common comparable scale. So we need to do this standard scalar step. And then if you're thinking about the context of dsci 100 and for the final exam or for all of the exams in dsci 100, you only know one answer for this, right? There's only one type of transformation that we've like really tested you on and try to hone home. Some of you for the group project might have used another transformer on top, but we don't necessarily need to talk about, you don't necessarily need that for the exam. So we're going to use a column transformer because we're going to transform our columns. We are going to put in our standard scalar because we need to standardize some data. And then the code looks like, hey, then we are going to go and pass in the variables or the columns that we need for scaling that data set. So if you forget like what's going on with this function, you should be able to say, hey, I need to do a data transformation step. Okay. Then the question is like, okay, you need to do a data transformation. That usually means like, what are you transforming and how are you transforming? In scikit-learn, it's sort of flipped the way I just said it. So you're doing the how are you transforming and then what are you transforming afterwards. So you can use, again, this block of text here, this block of code here to think through like, what do you need for the code? Why is the code formatted this way? And it can help you review a lot of the concepts as well, which is, I keep saying that because I don't want people to blindly just look at this code and like think that you can understand everything just by reading code. Like actually, I'm giving you all of these code pieces so you can literally copy paste it into your Jupyter lab and run it yourself. And after I run this, I'll show it to you and how you might want to use this on your own in a couple of ways. Then we have a pipelining step. So in this particular case, I'm saying like, hey, we need a k-nearest neighbors model object. We need to put in our preprocessor. We're turning that all into the pipeline. The other part that I want to urge people in understanding is the very first week of the class, we talked about assigning things to variables. And so this is an example of like, I know some students, when we were grading the midterm exam, like you only saw the word prep or preprocessor in your homework assignments. And then like, even if like this variable name changed for some reason, like you only memorize the code to the point where like, even if the variable name has changed, you were putting in the wrong answer. So again, um, those are those are like fair game, but they're not done that way to be like tricky for the exam. They're really there for you to be like, are you paying attention to the code that's actually being presented to you? So that's why I would say like it's not that you're always going to be given like different variable names for your exam, but that's how you go and fill these bits in, which is another way of me telling you that's why you don't want to necessarily memorize or just blindly copy paste code. Like try to work through and maybe type things out on your own as you're reviewing these code steps. For for the best of my ability, I'm trying to at least give you code where you can just, I know it works. So if something goes wrong, it's typically like you might have typed something wrong. I hope that's the case. So we're making a pipeline. Then the question is, okay, why does this line even exist? Part of it is you want to tie the data transformation to the actual model that you're fitting. And then it's also when we give this data or when we give this pipeline our testing set, you want the testing model, the data that went through the data from the testing set, you want the same exact transformation to be applied to the test data. So like you did all of this work standardizing, calculating averages and standard deviations from the training data set. You want that same information applied to the test data set because when it goes and calculates distances, it's still on the same standardized scale. So making this pipeline make sure that the components, the pre-processing step, if you were to go and use this model again, that all the transformation steps are happening together at the same time. Could you get away without making this pipelining step? Yes, we don't, we're gonna say like no for the context of the course and the exam, but could you get away with not using this step? You absolutely can, but then you run the risk of next time you're giving it new data, it's not being transformed and scaled properly, which then means that the results that the model's giving you is going to be incorrect and wrong. So the next section, it was actually one of the questions before I started recording was, okay, we are using k nearest neighbors. K nearest neighbors has a parameter called n neighbors because we need to figure out how many of the closest points we want to look at, right? So some of the things we do in dsci 100, there's only like so many answers because other than linear regression and k nearest neighbors, you don't know any other way to do regression. And so what is one of the ways that k nearest neighbors differs is you can't just fit k nearest neighbors on its own. You have to give it some value of k, or in this case n, that you need to fit the model. And each value of n is going to be a different model for k nearest neighbors. So here we're saying, hey, I want you to use all of these values from 1 to 201 and go in multiples of 3. And I think the answer is like this is creating 63 different models. We then use the grid search CV function to insert in all 63 different models to do cross validation. And the reason why this is set up is because some models have like another parameter, and then you can give it like a list of like 10, 20, 30. And now I have 63 times 3 different combinations of values that grid search CV can all plug in. So in this particular class, it's sort of, why are you doing it this way? It's like, seems like kind of a little bit extra, but it is a placeholder because when you use a different model that sometimes needs 2 inputs, you have the ability to try out all of those models. So we're setting here, hey, I want you to try values 1 to 201 in increments of 3 for k nearest neighbors. For the exam, do you have to use range? The answer is no. You can put in actual values, like maybe I want to try 50, 60, and 80 right here, as long as it comes back as some type of list container in Python. As long as it comes back in some list container in Python, then you're okay. So all this part here is, hey, here are all the numbers or values of k I want you to try. And then we're actually going to go and try those values of k. So we can't just go and fit like, I mean, you can go and fit k equals 1, k equals 3, k equals 5, fit it into the actual training data set. But then the reason why you can't necessarily do that is if you use all of your training set to fit the model, then you have nothing left to assess the model other than using the test set. And again, once you use it once, you can't really use it again, right? So we need to break our training set into two more pieces where the data we actually train on and like this fake testing data set. And instead of calling it a fake testing data set, we call it the validation data set. And so that's all of how cross validation works. So this portion here is actually, if you follow what this code is doing, it is actually a lot of things and components around how cross validation works. And then you ask yourself, why do you need cross validation? It's because, well, we're going to be trying 63 different models. And then we need a way to assess which of these 63 models is like the best model or a good model to use. And we don't want to burn up or use up the true testing data set in our trying different things, right? Because maybe you're gonna run this and be like, oh no, I forgot a variable, or oh no, I want to like remove some of these variables. If you've already gone through the whole process and used it on your testing data set, you kind of like can't do that anymore, right? So at least in theory, you shouldn't be doing that anymore, right? Because you've looked at the answer key and now you're making a decision based off of what you've seen in the answer key. So do you really trust that the next iteration is going to be performing better on data the model has never seen before? The answer is no. So that's what grid search CV is doing. It's all doing cross validation and it's handling like all of the values in this parameter that we can, like all the different combinations that we can use. And again, if you follow what's happening with the variable names, like I created this object, right? So like, yes, you're specifying things here. Pay attention to what variable this got assigned to because you need to use it somewhere else. So be mindful of like reading everything that's happening on that line of code. Grid search CV, you pass in the pipeline, you pass in the values you want to try, you try, usually you will specify like 5 or 10 fold in cross validation. And then you give it like how you want to score it. In this particular class, we're really only looking at RMSE or RMSE PE. Yes, yeah, question.
Yeah, I have a quick question just relating to the parameter grid. I think you said something about how we can plug just a straight like list into like param grid in grid search. And then because of that, I'm wondering why we have to specify k neighbors regressor underscore n underscore neighbors inside our param grid object.
Oh, okay, yes. That is because this is how. Oh, okay, I see. Uh, you're asking like, why can't you just put like something like this, like right here? I'm assuming. Like you're also asking like, why does this thing exist?
Yeah, exactly.
Okay, part of it is this bit here. I would say like I would not really test you on trying to fit in like this string because it's kind of annoying to deal with. This right here, this particular string is it looks like a string, but it's like secret code in scikit-learn, and that secret code is saying, "Hey, you created this model. That model has a parameter called n neighbors." So if you think about like classification one, where we first taught you, it was like k nearest neighbors and then n neighbors equal, like you manually put it in this way. So in scikit-learn, we can sort of abstract that and like automatically put in more values. And it's using this like special string notation. And the way it's special is because there's two underscores right between the model and like the inputs to the model. Like they do a bit of string processing to like put in the actual k neighbors parameter in the actual model. Um, so that's why the code looks like this. You can argue, is that the best way and why does it look like that? That's sort of like out of our control. So it does become like this is how it is. Um, then the question is like why do we why does this exist? Again, it is mostly there as hold on, let me actually run give me 1 second. Let me go and run, let's comment this out. And then let's replace this with like 1, 3, and 5. Believe. And then let's just fit and look at like all of these values. Um, yep. It's yeah. So you can't actually just go and put this in here because we're using grid search CV. So again, this part of the code, especially in regression one, um, because we're using cross validation, we can't just go and we have to tell the model like, hey, I actually want you to put some values in here, and I'm going to give you multiple values that's like coming from either a manual sequence or something that's pre-calculated from Python. So right here, you can't just put in 135 because given the pipeline, it's got this object. It doesn't know like, okay, you just gave me 135. Where do I put it in there? That's why we have this section is to sort of tell scikit-learn like, hey, you have this model. This model has this parameter literally called n underscore neighbors. Please put in like one, then three, then five. So that's why the code looks like that. And again, whether or not knowing the why the code looks like that, again, it is also more important that you understand like, hey, you do need to create like a parameter grid, even if it's one parameter, and then you're going to use that parameter because inside the parameter grid, it specifies which model and what variable you're plugging into that model. So hopefully that answered your question.
Yeah, that did. That was perfect. Thank you very
Okay.
much.
So and then you saw like when I tried to put in 135, it was like I don't know what you're trying to do in here, right? Because again, main thing is I just gave it three numbers. I had no idea where to put it, right? And again, part of this particular course in dsci 100 is we are working with more simple models. So then, you could make the argument like, well, it should know it goes there because there's only one thing to put in there. It's like, yes, true, but it's because we're also working on like a somewhat more simplified use case. Okay, so we're going to go and fit cross validation, or sorry, not fit it. We're going to set up all of the cross validation bits, and then we're going to go fit it. And this is going to take a little bit of time because, again, under the hood, I'm running 63 different models. And the more I say that, I feel like we should not do 63 different models. We should do like half of that. So I'll make the number, actually, I'll make that even smaller. I think 72. That would work. Yeah. We'll try fewer models just so if you try to run it, it's a lot faster. So this is going to go and fit the actual model. Now that if we're thinking about why does this line exist, everything that we've done right so far was setting up the actual model, like just preparing and setting things up. We haven't actually gone and um, done the actual model fitting, right? So if you think about in the textbook, you had like an actual K nearest neighbors linear regression model, and it's like this squiggly little line. We haven't drawn that squiggly little line yet. We just set everything up. So right now, what is it doing? It is now actually doing cross validation. So we have another opportunity to think about and review what is happening on this particular line of code, which is what's happening with cross validation, which is okay, we have our training set for X, which is our inputs and the actual answer. And then within the X training set, we're splitting it into 5 different pieces. That's what the CV5 is for. And so it's essentially doing training testing, but that training testing is happening completely on the original training data set. So again, the training data set that we work with in the cross validation step is really called training and validation because the true testing data is the final check, right? So how many folds do we have? We have 5 folds. That means we take our training data set, split it into 5. So every single iteration of a model fit, it is fitting on 4 of those 5 pieces and then doing a predict on that 5th piece and then calculating RMSPE because we're using regression right now. So a lot of stuff is happening in this one line, right? So again, don't think about it as, okay, you're fitting the model and then you're doing dot fit. That is not the way. Like that can get you through the coding aspects of the course or the exam, but that's not going to get you through the short answer part of the exam, right? You really do have to think through it. And again, it is really easy to like, oh, okay, now you fit. And then you completely just like overlook everything that's going on with cross validation. So be like slow down. It's not just memorizing. I'm hoping it's not the exam. I'm hoping that there's enough breadcrumbs to guide you through where you shouldn't be memorizing every single component. It really is thinking about what is happening. And again, part of that is also paying attention to the variable names, paying attention to like what step are you in right now. Um, luckily in dsci 100, we're not at a testing scenario where like I'm showing you incorrect code and you telling me why the code's wrong. But you do need to pay attention like with the flow of what's happening. So if we even review up to this point, like we have a data set, we are pre-processing our data, we have the model that we want to connect it together in a pipeline. Oh, k nearest neighbors has different values of k we want to try out. So here's the values I want you to try. We're going to set up all the ways that you can plug in 1 to 72 by 3. In this case, it's only one way you can set with that set of combinations. So it's okay. It's a little bit redundant, but that's okay. And then we do the actual cross validation. I've talked long enough that the model actually finally fit. And then we can go and look at our results. And so here's all of the models that were fit. 67 models that were fit. If we try to run it now, it won't be 67 because I reduced the number of k. But then you see, like it tried k equals 1, k equals 1 plus 3. So it gave me 4, right? So this portion right here says start from 1, go in increments at 3, stop at whatever this number in the middle is. And we see it. Start at 1, increment by 3. So it's trying k equals 1, 4, 7, 10, 13, et cetera, et cetera, et cetera, et cetera. For k equals 1, it's doing it 5 times because we have 5 folds in our cross validation. And each of our folds, you'll see like we have split 1, 2, 3, 4, 5. And then because we have 5 numbers, it gives us the average of those 5. And this is the RMSPE value that was calculated. Um, yeah. So that's why we have 67 of these values, models. Sorry, let me rephrase that. We have 67 models or 67 rows because originally this said 201. So there were 67 uh, increments of 3 that was happening. Each one of those 67, 5 models were fit because of cross validation is equal to 5. So if you really think about how many models were fit, it was 67 times 5 models that were fit because of 5 folds and cross validation. So I reset that just so that part's really clear. So that's why it takes a lot of time. So that's looking at the results. But then the question is, so like this portion right here, do we really need this? No. This section, if you're trying to remember code, may or may not be there in exam because this is here just to show you what's happening with the results. It's there for you to try to understand what's happening with cross validation. But if I really think about, do I really need these 3 lines if I only care about fitting a model? No. Whether or not those results were there or not doesn't affect the rest of the code below. But then the question is, why are we doing this to begin with, right? Like, why do we even bother to do cross validation? And then the question we had before I started recording was like, linear regression doesn't have cross validation, right? Like, why were you even doing this? The reason why we're doing this is because for k nearest neighbors, we have to go and figure out the best value of k that we need to do, right? So luckily, scikit-learn automatically saves us the best param. So it says like, okay, whatever model I did, k equals 10 is the best. So we can probably definitely reduce this number down because you don't need to run that code for a long time. So we can even say like 21, just so it runs a lot faster on your computer. And so Now, if I were to run that process, just to show you what this output looks like, and so it's in the recording that the code is different from what I'll submit and update, you'll see that we have 6 models now, right? We have 6 rows now. Why? Because we have here from 1 to 21 in increments of 3, we only have 1, 4, 7, 10, 13, 16, 19, 21, right? Those are the only like, or is that right? Oh yeah. Okay. I guess it's not going to 21. But those are all of the K values that were tried. But you're still fitting 5 different splits because you still have CB equals 5. And again, what I just did, like tweaking some of these values, that is how I want you to also study for this exam, which is what is happening with the lines of code. And I'm giving you the lines of code and I'm giving you the sample code that works because I want you, as you're reviewing, to like some of these things you can try and change the values of, and you can see how the output differs, which means that sometimes the values will actually come out different. Right. So for example, if I tried only 1, 3, and 5, this value here for best params would never show up 10 because 10 never got ran for values of K. Right. So you can see how um, the outputs and things like that will change. Okay. So now we have, after this step here, we actually have the best model already. Like it already knows to use our data set with K equals 10 because I already found out that it was the best model. So if you think about the next step in cross validation, we needed to retrain the entire model on the full test data set. And I believe like scikit-learn already does that for you automatically. Well, once it finds out the best parameter. But that is a step that needs to happen. So again, remember cross-validation, like we did all of this stuff to find the best value of K. So we need that best value of K in K nearest neighbors. And then we're going to train it on the full training set, even though we've used so much of it already for validation and testing and things like that. We want the actual full model with all of the data that we are supposed to be using, which is the full training set. And then we take that fully trained model on our training set, and then we can use it on our test set. So there might be more stuff in here to show you what's going on, but again, it's more important that you are following the overall steps of what's happening in trying to fit this model, and telling that story of how this model gets fit actually will completely cover everything you need to know for the short answer portion of the exam. So we are going to go and run predict on our testing set. Why are we doing predict on our testing set? Well, if we really think about this line and if we sort of think about everything that we learned in dsci 100, this is a supervised machine learning model, which means that we actually have the correct answers for the model that we have fit. So we are going to run predict on the testing set for just the X portion or the inputs or the predictors, because it gives us predicted values. And then we can take those predicted values and compare it to housing Y test, right? So here's like the actual values and here's the predicted values, right? And so you can see here, it predicted 0.54, but the actual value was 0.477. So what you can do is calculate how much error happened from the model and its predicted value on the test set versus the actual values from the test set. So we are now literally at the point where there's a scatter plot. We drew our squiggly lines. Now we're calculating like the vertical height of the red bars and doing our MSPE calculation from there. So yes, really small example, but you can see like even though we went through like 95 lines of code, It still roughly took me like 40 minutes to like talk through it. But that's how I want you to think about this particular type of problem. I have more office hour sessions. We'll go through more of I'll provide more examples we can go through more, but I wanted this first example to use regression because it covers so many concepts that we've learned in class. You still also have the example for linear regression 2 or regression 2, which is the same exact code from regression 1, but the only difference here is we're using linear regression. And again, you'll notice in this particular set of the code, I never use cross-validation because given one set of models where I am using all of the training data for the X columns and the one column for the Y, I'm using all of the columns in our data set. There's only one way to fit a line given one set of variables. So cross-validation doesn't exist in this context. And we don't need it to because we're only fitting one set of variables. If I were trying multiple combinations of variables, maybe I would be using cross-validation because I can go and use the average RMSPE from cross-validation to see which combination of variables behave better. And in this particular class, and I believe in this machine learning context, it might end up. Don't be surprised if it ends up being like you ended up doing all this work just to say pick all the columns. But that would be one case why you would use cross validation in a linear regression context. But we don't really do that in dsci 100. Okay, the last thing that I want to cover is how do you go and run this code on your own? So like I kept talking about like run your code, test it for yourself. There is a link in our Canvas page. You can see from the course information, if you scroll from that first Canvas module, there is a code review session module. If you click on it, you go to the little GitHub page where all of this is. And I just did a couple of edits today and last night. So it should not say 2 weeks ago. It should end up saying like from Friday would be the last update. But this is all the code that you have. You can click through the files and just get all of the code. So you don't have to run it like I just did on VS Code or whatever. The most important thing is you have that code. And that's because once you have the code, you can literally copy this code, go back to your course, Jupyter lab session, click on the little home folder. So you're in outside of the student folder. It's like kind of a good practice and make a new notebook that says, what should we call this? We will call this regression one review. And so the easiest thing you can do is very literally copy paste this. And I'm going to just say like 12 here, just so it doesn't run very long. So copy paste the whole thing, run it, and then this should not error on your computer, right? Like it's running through all of the code that I just had for you. So it's dumping out all of the little bits. Do that just to prove to yourself that the code actually works. But just because the code works doesn't mean this is how you should be studying and using this code for the exam. So what do I mean by that? I mean, you should end up like after the part of the code that I say you don't need to worry about, I would, just like in your assignments, I would end up saying, okay, we're going to run all of this because that's code that sets it up for this example, and I don't need to look at it, but I can look at the data set if I want to. Then one section at a time, go through and add the code piece by piece, which is saying don't add all of the code in one giant code chunk. Do it in separate steps after you see that the code actually works on your computer. The reason for that is this gives you the ability to say, hey, what does the preprocessor object look like? What's happening in here? And you can see like, oh, this used all of these variables. Where did all of these variables came from? Is because it was specified right here. You can look at the pipeline object and you can see like, oh, it's putting everything together, right? So In this case, like, are we going to say like only make me the pipeline, or what does this picture look like and what does it mean? We're not going to ask you about that. But if you're curious or trying to help you slow down to like what is happening here, like describe what is this pipeline object, because you need to know why we're using this pipeline object. It's so we have our k nearest neighbor object, we have this column transformer, and we only know about this standard scalar. Like that's why I want you to look at all of these small pieces, because it'll help you explain why does this step exist. So that's how you can use the code in a brand new Jupyter Notebook session to help you study for the exam. The last thing I want to show you is, I know that everyone, like if I say, do you use ChatGPT? Uh, you are lying, I believe, if you say no. So let's take this code and um, show you how I would use this code even more to help you for the actual exam. I believe it's smart enough that if you give it the code that you are actually responsible for and can be tested on, you can copy this section here. So all this bits up here around like setting up the data and stuff, like you don't really need. So let's go and copy all of this code down here. Yep. All right, let's copy this code. And let's put in, you can put in something like, um, I'm taking an intro programming exam. I have fill in the blank coding questions. Can you provide 4 to 6 blanks for this example code to help me study? And then also give me the, right, and then paste in that code. And literally just have ChatGPT do it for you, right? So if you look at the output from here, this looks very much like the coding questions you will be given for the exam. So the coding, the actual lines of code help you, if you think about it, line by line, will prepare you for all of the non fill in the blank coding portions. And then very literally use ChatGPT or Claude. Claude is also very good at doing this type of stuff. And ask it to give you 4 to 6 blanks. You're only going to be asked 4 to 6 blanks for like a block of code. The only time you'll get more is like what I did during the midterm, which I don't think I'll try not to do. Is I combined 2 questions together, so you had more than 4, but 1 question of fill in blank is going to be 4 to 6. And so this again looks very much like what you would expect on the exam. So go and try to fill in the blanks here. And then it gives you an answer key. That's actually kind of nice. And then, you can very literally, uh, where is my, you can go back to ChatGPT and say, give me another set of blanks. And then it'll give you another set of blanks. I don't know if it gave you the same one, but it'll give you another set, right? So you can totally use that to help you study for what's happening with the fill in the blank portion. And if you, again, this code should work. So if you want, you can fill in the blank and then test yourself, go back to your Jupyter notebook and run that code, and it should run without any errors. Is why I'm spending so much time giving you like code that works from top to bottom. There's a couple of things in here. I realized that Palmer Penguins isn't installed on your computer, so I'm swapping out data sets from all of the examples that I have. But that's how I want you to prepare and study for the exam. And it should help a lot if you do it that way. I hope the chat GPT portion got saved. Um, but yeah, because I realized I might have pause the screen share. So I'll talk about it again just so it's there. This is the little prompt that I used. I pasted in that particular piece of code, and it was giving me these actual blanks. And then if you want, you can go and give you another set. Um, Internally, if you really care, don't do this over and over and over again. It's actually better to create more separate chats than keep talking to the same chat. Um, that's just a little tip, just knowing how these types of models work if you want to save on the token count before ChatGPT sort of tells you you're out of tokens for the day. It's much better to start a new chat than keep having the same conversation through the same chat. So that's just a little tip on that side. All right. Um, that's everything I wanted to talk about. I know we had a couple of questions in the beginning, which is why I wanted to try to split this up like 50-50, but it's really 70-30. Um, but yeah, so I'll start putting up more and more example code. There's already everything from the midterm on, and I'm going to be filling in some code from pre-midterm. But just as another reminder, the final exam, the way I would think about it is 1.5 times the midterm, which is it's the same size of the exam that you took for the midterm, but only focused on midterm to the end of class material. And then the content from the midterm is half of that. So you have the size of the midterm plus half its size, and the weight of the materials is focused on the second half of the class. The first half, it's sort of it's not as we're not going to be testing you too heavily on it, because things like how do you assign variables, you're going to be seeing it. You've done that all semester. But we'll talk more about tidying data. That's like one of the more important concepts that came out of the midterm session. For visualizations, it was around data, the type of data that was stored in a column. So those are things that we'll talk about in the office hour sessions next week. But I definitely want to make sure that this first set of office hours that got recorded at least covered how you can use everything that we've been giving you to help you study for the exam. All right. Oh, people were typing things. Yes, you can totally plug in the textbook chapters. ChatGPT, they have a lot of these tools now that can read websites. So I would say there are a lot of extra stuff from the textbook that you're not going to be tested on, especially in the fill in the blanks section. So if you look through the textbook, when we fit a model, we also do a lot of extra code for like plotting and looking at other results. The exam coding portion is a lot more straightforward. We're not going to have you run like a separate side analysis in one fill in the blank question. So, um, so how does the final split between midterm one and the later content? It's essentially the content from midterm one, the topics from midterm one were still fair game. It is the number of questions is half of the actual midterm. So think of what you did in the midterm, cut that in half, and that's how much content from the midterm is going to be on the final. And then if you think about the rest of the exam, it is the size of the midterm, so same number of questions, but only on the content after the midterm. So that's why I say if you think about the number of questions, it's 1.5 times the midterm. The 1 is going to be the newer content, and the 0.5 is going to be the midterm components. Yes. So the coding portion of the final will be mostly focused on the stuff I've demonstrated. Yes. And there's some midterm things. So, same concept, like why is this figure drawn incorrectly? Fill in the blank for like this figure. Uh, there will be questions around like melting and pivoting. for tidying data. So those are all fair game, just much less questions than the midterm, but they'll still be there. And the format will be exactly the same. So, which is why you have the code that I am giving you and use ChatGPT to give you the blanks for it. You can even say like change up some of the variable names as well, just so you're not only used to looking at like prep or pre-process, right? Some people ended up providing like the answers from the homework, but not the answers that we were looking for in the exam. All right. So we're a little bit off time. I'm like actually running late for something, but um, we have another set of office hours on Monday and Tuesday, and then the exams on Thursday. So, and then as soon as Zoom deals with processing the recording, it'll be up. All right. Take care, everyone.